C2SMART Center uses cities as living laboratories to study challenging transportation problems and find solutions based on the recent advances in artificial intelligence and communication and other smart technologies. In the wake of the COVID-19 outbreak, stay-at-home and social distancing policies caused an unprecedented shift in demand and usage of global transportation systems. Since the start of the pandemic, C2SMART Center researchers have been integrating publicly available transportation data resources into an interactive data dashboard to investigate the impact of COVID-19 on mobility and travel behavior.
One of the most innovative and timely research efforts was in using artificial intelligence methods to develop a deep learning object detection method to use live video feeds from public traffic cameras to determine pedestrian and traffic volume densities on city streets and sidewalks. To do this, the research team used deep learning and reinforcement learning, a generalized reference-free distance approximation method, combined with an open-source pre-trained object detection model and several post-processing filters, provided the ability to track pedestrian density and spacing. The real pixel distance rate method that was developed is able to approximate distance between a pair of pedestrians, regardless of the different perspectives or views of the cameras. This AI-based framework is capable of real-time implementation and was scaled up to apply to use cases such as vehicular volumes and densities, detection of parking and bus lane occupancy, double parking, and densities at bus stops to assess transit demand. The team is now using a reinforcement learning approach to retrain and automatically optimize the detection algorithm with localized annotations in order to continuously improve the detection rate for hard-to-detect vehicles like bicycles during rain or snow or other challenging conditions. This method has been able to produce data at over 60 locations in New York City using footage from New York City Department of Transportation cameras, and its feasibility has also been tested by University of Washington researchers in downtown Seattle on different types of equipment and topography. The scalable work presents a groundbreaking opportunity to use artificial intelligence for large-scale data collection on transportation system usage without any major capital investments.
Artificial intelligence allows us to continuously learn and adapt as the environment around us changes. One way that C2SMART has been thinking about this type of continual improvement is through our WorkZone worker safety project, which uses AI to adaptively and continuously test road construction zone danger notifications based on worker response. Smarter alert and advanced warning systems are necessary, but live testing these systems can be costly and time-consuming, while also putting both roadway construction workers and drivers at risk. Researchers at the C2SMART Center have sought to alleviate this problem by building a cyber-physical testbed, populated with real-world data to explore worker behavior using artificial intelligence and machine learning to adapt and improve notification alerts for safer work zones. The first phase of work highlighted the need to focus on worker rather than driver behavior. We identified the construction site type where alerts are least effective, and the rate of worker fatality is the most acute, short-term and mobile work zones. We developed an integrated testbed platform to observe workers perform tasks in simulated roadway work zones while testing a variety of hardware, such as smartwatch and physical sensors that generate hazard notifications of various types, durations, and frequency. The virtual reality testbed was built from 3D laser scan traffic areas and linked with real-time traffic simulations to create 3 highly realistic test sites modeled after real road locations in New York City. Vehicles movement in VR will respond to worker actions and behaviors the way a driver might brake suddenly if they see a pedestrian walk into the road. The current phase of the project uses reinforcement learning to measure and effectively adapt a smartwatch notification system to workers' physiological and behavioral response within the virtual reality environment. The AI-based system maps heart rate, eye movement, and other types of worker response to learn how workers react not only to hazard notifications, but to the hazards themselves. It can then account for these reactions and tailor notification settings, such as duration and frequency of vibrations, to ensure the worker's overall awareness of hazards and life safety. Conducting tests in a VR environment avoids the issue of endangering workers with live site tests, and the AI techniques open doors for individualized alert systems, enabling the development of a notification system that is tailored to not just broad behaviors, but individual response.
Research at C2SMART and other USDOT centers have incorporated AI to create solutions ranging from big data collection to autonomous driving. As these advances continue, AI research can help create a better and safer transportation for tomorrow.